Welcome back, students. In this session, we are going to discuss air pollution. We'll discuss all the sources of air pollution. We'll see the causes of air pollution. We'll see all the pollutants which are related to air pollution and the effects that pollution has on humans as well as on the environment. We'll see all that. But before we begin with all that factual information about air pollution, we'll discuss some facts. And these are the facts which should be alarming for any human being. Air pollution is the world's single largest environmental risk to health. More than 6.5 million people across the world die prematurely from air pollution every year. We are talking about 6.5 million people. 90% of the people are inhaling air which is unfit for them according to WHO limit. So 90% people are breathing air which is not fit for breathing as per the guidelines that have been set by WHO. Now approximately 5,70,000 children, 5,70,000 children under the age of 5 years are dying from respiratory infections such as pneumonia, which can be attributed to air pollution, indoor and outdoor. What is indoor, what is outdoor? We'll come to that. Second-hand smoke is also a huge reason causing various respiratory infections every year. Apart from the kinds of infections and disturbances that is happening to the humans, air pollutants cause climate change also, and we are very much aware of the fact that there is something called as global warming happening. So what is global warming? We'll look into it. Acid rain is another thing that comes out of air pollution. We'll discuss that. Greenhouse effect has to be discussed. Apart from that, you might have heard of ozone hole. What is ozone hole? We'll just come to that after we have finished these parts. So all these kind of issues are related to air pollution. Such is the magnitude of air pollution. Another data if I have to give you, the increase in ozone hole is decreasing the productivity of crops like wheat, crops like soya bean, maize, etc. by up to 26%, and this might happen by 2030. And this would impose cost of approximately 17 to 35 billion dollars. So if you look at all these data that you have with respect to air pollution, you should know the severity of situation. Now let's come to Delhi. The image that you see here is a very common image, and this is an image that is seen every year in the winters in Delhi. And this is something which is related to smog. What is smog? We'll discuss that also towards the end of the lectures. Or if you look at the image, something like this. This is an image which we are used to seeing, but we should not be. The case of Delhi, if we talk about it, 2016 November was when we saw severity of air pollution. Delhi earned the unequivocal distinction of becoming the most polluted city on earth in the month of November 2016. The air quality had reached especially bad proportions in 2016. So the air quality index that we measure showed a reading of 999. The funny thing about this number 999 is that the air quality index does not go beyond 999. There was one very sensitive air quality index measurement device with the US Embassy, and that showed a reading of 1010. So such was the severity that we saw. And since then we have been trying different kinds of solutions to the menace of air pollution in the Delhi and NCR region. So let's start with the discussion on air pollution, and before we do that, let's first discuss the atmosphere. So first of all, atmosphere is a topic that I'm very sure that you have done in geography. In the climatology part, you might have read everything. If you have not, go back, read the nature of atmosphere from geography part, and then you can come back to it, but you do not need the knowledge of that part. So first of all, we need to know about the atmosphere. So if I talk about the atmosphere very briefly, every one of us know that we live under a very thin blanket of gases which is surrounding the earth, which is called as atmosphere. and it has been divided into several layers. In this unit, what we are going to discuss is only two things: the innermost parts, that is troposphere and stratosphere. So approximately 75 to 80% of Earth's mass is found in the troposphere, and this layer extends only about 17 kilometers above the sea level at the equator and 6 kilometers above the sea level over the poles. Then, so if I have to give you an analogy that how much is the atmosphere, you take any fruit which has a very thin skin, let's say apple. So if you take apple, if the earth is the apple, the atmosphere is the size of the skin of the apple, only that much. So if you look at the next line, about 99% of the air consists of two gases, nitrogen and oxygen. 78% is nitrogen and 21% is oxygen. Apart from that, you have other such as water vapor, argon, carbon dioxide, trace amounts of dust and soot particles, as well as other gases including methane, ozone and nitrous oxide. So all these quantities are in very, very small amounts. For example, if we talk about argon, let's say, argon is just 0.93%. Carbon dioxide 0.04%. So all these are very trace amounts. So majority of it is nitrogen and oxygen. Then rising and falling air currents, winds and concentration of carbon dioxide and other greenhouse gases in the troposphere play a major role in planet's short-term weather and long-term climate. And this distinction between climate and weather, I am very sure that all of you are very much aware of. Then if we talk about the second layer that we have, which is stratosphere. Stratosphere extends from 17 to about 48 kilometers above the Earth's surface. Then much of atmosphere's small amount of ozone is concentrated in a portion of the stratosphere called as ozone layer, found roughly 17 to 26 kilometers above the sea level. So if you have to compare stratosphere and troposphere, there are two notable differences that we have. First is that the volume of water vapor in stratosphere is approximately 1 by 1000 of what you have in troposphere, and secondly, the concentration of ozone is much higher in stratosphere as compared to troposphere. Then now again, if you look at this point, that most of the stratospheric ozone is produced when some oxygen molecules in this layer interact with the ultraviolet radiations that are emitted by the sun. So this global sunscreen of ozone in the stratosphere keeps about 95% of the sun's harmful UV radiation from reaching the Earth's surface. So this is the role of atmosphere. So next, let's see what are the sources of air pollution and what are the pollutants that we have. Now, air pollution generally results from industrial emissions, from thermal power stations, from automobiles, but also sometimes from the domestic usage that we have. So let's have a look at them. First of all, you have industrial chimney waste. So there are a number of industries which are sources of pollution, and we are all aware of it. Petroleum refineries are major sources of gaseous pollutants. The chief gases, if we talk about them, you have sulfur dioxide, right? You have nitrogen oxides, then, and you also have other gases. So if we take the example of Mathura, the petroleum refinery that we have at Mathura, that is causing a threat to Taj Mahal in Agra and other monuments at Fatehpur Sikri. The cement factories emit plenty of dust which potentially become health hazards. Stone crushers and hot mix plants, they also create a menace. Then the particulate matter level, and you might have heard of this PM 2.5 and PM 10, and we'll come to what is PM 2.5 and PM 10. So the levels of this PM or particulate matter in these kind of areas where stone crushers etc. are placed is 5 times more than industrial safety limits. Then there are many foods and fertilizer industries which emit gaseous pollutants. Even if you talk about chemical manufacturing industries, they also emit a large amount of acid vapors in the air. Then, if you talk about the thermal power stations, the coal consumption of thermal power plants is 7 million tons. The chief pollutants here, if we discuss this, is fly ash, right? Then you have sulfur dioxide, and then you also have other gases and some of the hydrocarbons which come out from here. And while we are discussing thermal power stations, we can discuss the case of Korba, which is situated in Chhattisgarh. How it transformed from a power hub to a pollution hub. The thermal power stations by NTPC and other companies that exist there, they have caused a lot of pollution. In 2009, there was one study which was done by Central Pollution Control Board, and it ranked 5th amongst all the critically polluted areas. So such has been the case. Now there was a notification given where they were asked that all the fly ash that is generated in Korba, that should be used. Now this ruling was given in 2011, and until now we have not even seen 50% usage of approximately 1 million metric tons of fly ash that is generated in Korba itself. So we are just talking about one of the areas in entire country, and such has been the situation everywhere else. Then the third source of air pollution that you have is automobile. Now the toxic vehicular exhausts are a source of considerable air pollution next only to thermal power stations. The increasing vehicle traffic density that poses continuous threat to the ambient air quality has been observed everywhere in India. The number of automobiles is also increasing in all the metro cities and even other urban areas as well. In all the major metropolitan cities, the vehicular exhaust accounts for more than 70% of all the carbon monoxide, 50% of all the hydrocarbons, 30 to 40% of all the oxides, and 30% of all the particulate matter. You can even note this now, that 70% of carbon monoxide accounts for 50% of all the hydrocarbons. Then after that, you can say that 30 to 40% of all the particulate matters. So such is the situation of the metros. And during the peak automobile hours, all classes of automobiles emit large amounts of carbon monoxide, hydrocarbons, and other oxides such as nitrogen oxides as well. The two-wheelers and three-wheelers contribute 60% of total carbon dioxide and 83% of total hydrocarbon, whereas if we talk about the heavy traffic vehicles, approximately you can say 60 to 80% of oxides of nitrogen are generated by them. So such is the severity of the issue. So if we talk about automobiles, what are the sources of pollution in automobiles? First of all, you have the exhaust system, you have the fuel tank, you have the crankcase. All these basically are polluting the environment. The exhaust produces many air pollutants. For example, the hydrocarbons, the carbon monoxide, nitrogen oxides, lead oxides. Then there are traces of aldehydes, peroxides, ketones. So all these also are chemically active, and they combine together to form smog. You may have heard of this term, and we'll discuss what is smog. So let's come to the pollutants now. All these pollutants that we have listed out here, let's come to that. So the kinds of pollutants that you have is carbon compounds. Carbon compounds, mainly you have carbon monoxide and carbon dioxide. Then you have nitrogen compounds, as we discussed. You have nitrous oxide, you have nitric oxide, and you have nitrogen dioxide. Sulfur compounds, mainly you have sulfur dioxide, some amount of sulfur trioxide as well. Then you have volatile organic compounds, you have ozone, and you have particulate matter, which is of two kinds. One is PM10 and one is PM2.5. So what is PM10, 2.5? We'll come back to it. So just quickly have a look at this particular diagram that we have here. It gives you a proper idea about what kind of activities is involved with what kind of pollutant, what is the immediate effect of these pollutants, and what can be the impact of this pollutant. So for example, let's say if we just talk pollutant, look at this particular diagram that 10 and one is PM 2.5. So what is PM10 2.5? We'll come back to it. So just quickly have a look at this particular diagram that we have here. It gives you a proper idea about what kind of activities is involved with what kind of pollutant, what is the immediate effect of these pollutants, and what can be the impact of this pollutant. So for example, let's say if we just talk about the transport part. So from the transport part, we get sulfur dioxide, particulate matter, nitrogen oxides, as well as volatile organic compounds. So only thing that is missing here is NH3 or ammonia. Correct. And then you have this pollutant causing these many problems. So if we just discuss sulfur dioxide, I can see that the PM concentration, that is particulate matter concentration, would be increased due to sulfur dioxide, and acidic deposition or something called as, or something that would lead to acid rain would increase in case of sulfur dioxide. So two major concerns that I would have with sulfur dioxide would be PM concentration, which is also associated with smog. So that's why just go back to, and I am very sure that every one of you knows this story of Delhi that we are looking at each and every year. Not only Delhi, the entire northern plains we are looking at. So what we see is that there is smog, and this smog is largely because of PM or particulate matter. And what is one of the chief components of particulate matter? Sulfur dioxide. Where is it coming from? It is coming from the vehicles. So that's why we are saying that with increased vehicular pollution, smog situation in these areas is worsening. And it's not the case with only in India. We have seen in the past with Mexico City, faced a huge amount of problem. Same was the case with China. In Beijing also we saw this problem. And there is one phenomena which has become very, very common these days, is called as Asian brown cloud. This smog has been named as Asian brown cloud because it is predominant in the areas of Indian subcontinent and China. Correct? So pause here for a minute. You can just observe what kind of activity is causing what kind of problem, what kind of impact it has, what kind of pollutant it is associated with. This is very, very important for you to know, especially from prelims point of view. So let's say they ask you a very simple question, that which of the following chemicals is associated with acid rain, right? So if they ask you this question, you see that there are three sources: sulfur dioxide, ammonia, and nitrogen oxides. So that's why this kind of question is very, very easy to be asked in the question paper, and often we have seen a question coming from here, not only in UPSC but also in the state level examinations. So that's why this particular diagram is very, very important. So just have a look here. You can pause for a minute and you can see it. Next, we will move on to all the pollutants that we have. We will take up the carbon compounds first. Once we are done with carbon compounds, we'll move to sulfur compounds. And one by one, after that, we will have a look at oxides of nitrogen and so on and so forth. So, first of all, we have carbon dioxide. Now, if you see the first line, major amount of carbon dioxide is released in the atmosphere from burning of fossil fuel for domestic cooking, as well as from heating and the fuel that is consumed in the furnaces of power plants, industries, hot mix plants, etc. Then from the fossil fuel alone, more than 18 into 10 to the power of 12 tons of carbon dioxide is being released into the atmosphere every year. Apart from that, if we talk about our country, on an average what we see is that thermal power plants are likely to release around 15 million tons of carbon dioxide in the atmosphere. Then even if we talk about the Indian coal, they have a very high ash content, that is 20 to 30%, and even at times up to 45%. So that is a very bad quality ash, and this also causes a huge amount of problem for our atmosphere. Then next you have carbon monoxide. So the chief sources, if we talk about, first of all, automobiles, then apart from that, the stoves, the furnaces, forest fires, factories, power plants, all these are also a major source of carbon monoxide. So if you look at this particular data, as much as 80% of automobile emissions and for more than 60% of all the major pollutants added into the atmosphere comprises of carbon monoxide. So in air, the concentration is from very trace amounts to up to 0.5 parts per million, or in short we call it as ppm. So but the problem is that if we talk about the urban areas, we see that the range is from 5 to 50 parts per million, and moreover, with incomplete combustion of domestic fuel in domestic environment, we saw huge amount of carbon monoxide source coming from there as well. Now, one very, very important fact that you need to know about carbon monoxide is that it can form carboxyl hemoglobin when it combines with your blood. So it combines with hemoglobin of the blood, reducing its oxygen carrying capacity. Now the fact is also that the reaction rate of carbon monoxide is very, very high as compared to oxygen. You can say that it's approximately 200 times of the reaction rate of oxygen with blood. So it mixes with blood much more easily than oxygen. So formation of carboxyl hemoglobin decreases the overall oxygen carrying capacity of the blood cells, and that finally results into oxygen deficiency, that is hypoxia. So this is a very, very important part. Carboxyl hemoglobin, please remember this particular term. And what is that? Basically, mixing of carbon monoxide with hemoglobin of the blood, and since its reaction rate is very fast, it can combine with the blood hemoglobin very, very fast as compared to oxygen, and that problem causes all the problems, and it can even become fatal for the people who are inhaling it. So if you look at a few data with respect to carbon monoxide and how with increasing concentration you see that different kinds of issues happen with the individuals. So for example, at 200 parts per million, we see that headache and reduced mental activity happens. Above 300 parts per million, throbbing headache followed with vomiting and collapse can happen. 500 ppm, person can reach into coma, and at 1000 ppm, there is a possibility of death. Next we have sulfur compounds. So sulfur compounds, among the sulfur compounds, the most important one is sulfur dioxide. So sulfur dioxide is a colorless gas with an irritating odor. Now 1/3 of all the sulfur dioxide that we have in the atmosphere comes from sulfur cycle, but the problem is the other 2/3 that is coming from human activities. What kind of human activities? You have thermal power plants, you have oil refineries, you have smelting of sulfide ores. So all these kind of industrial processes are also contributing to increasing the amount of sulfur dioxide in the atmosphere. So in the atmosphere, sulfur dioxide can be converted into aerosols. We'll discuss aerosols, which consist of microscopic suspended droplets of sulfuric acid and suspended particles of sulfate that return to the earth as a component of acid deposition, and this is a part of acid rain. Then sulfur dioxide, sulfuric acid droplets and sulfate particles reduce the visibility and aggravate the breathing problems. They can also damage crops, trees, soil, aquatic life in lakes, and they corrode metals and damage paints, paper, leather and stone. So all these things are attributed to sulfur dioxide. Then another important compound with respect to sulfur is hydrogen sulfide, or in short form you can write it as H2S. Now at a low concentration, hydrogen sulfide causes headache, nausea, collapse, coma, or a possibility of final death. Concentration, if it goes beyond 150 ppm, it may cause conjunctivitis and irritation of mucous membrane. And if it goes beyond 500 ppm, and even that happens for, let's say, even for 15, 20, 25 minutes, then, and finally if the exposure is at 500 ppm for even 15 to 30 minutes, there is a possibility that diarrhea and bronchial pneumonia may happen. So hydrogen sulfide, what is the chief source? So first of all, the chief source is decaying vegetation, animal matter, especially in the aquatic habitat. Then sulfur springs, volcanic eruptions, coal pits, sewers also give this kind of gas. Finally, approximately 30 million tons of it everywhere is released by oceans, and 60 to 80 million tons every year by land. Now even industries, if we talk about the industries, they emit approximately 3 million tons of hydrogen sulfide every year. So next let's discuss nitrogen oxides. So nitrogen oxides, and not only nitrogen oxides but also nitric acid. So nitrogen oxides, first of all we'll discuss nitric oxide. Now nitric oxide is also a colorless gas, and it forms when nitrogen and oxygen gas in air react at high combustion temperatures in automobiles and in coal burning power and industrial plants. Now if you look at the second point, lightning and certain bacterial activities in soil and water also produce nitric oxide as a part of the nitrogen cycle that we discussed. Then in the air, what happens is this nitric oxide reacts with oxygen to form nitrogen dioxide. So this is what happens in the atmosphere, and this is a reddish brown gas. Then apart from that, some of this nitrogen dioxide can react with water vapor in the atmosphere to form nitric acid, that is HNO3, and some nitrate salts along with, and this basically also contributes to acid rain. So for acid rain, remember two very important oxides. One is nitrogen dioxide and the second one is sulfur dioxide. So these are the two major components of acid rain. Anyway, towards the last part of this lecture, we will discuss acid rain also in detail. Then if you look at the next point, photochemical smog is also attributed to nitrogen dioxide and nitric oxide. Apart from that, nitrous oxide, that is N2O, is emitted from fertilizers and animal waste and is also produced by burning of fossil fuels. So this is the third nitrogen oxide that we are discussing. And please remember, this nitrous oxide is also a greenhouse gas. We'll discuss greenhouse gases in detail once we come to greenhouse effect, but remember this word. So again, at high level, nitrogen oxides can irritate the eyes, nose and throat. They can aggravate the lung ailments such as asthma and bronchitis, and suppress plant growth and reduce visibility when they are converted into nitric acid and nitrate salts. Now please remember, all these facts that we are looking at, whether with respect to the nitrogen oxides or with respect to sulfur dioxide and hydrogen sulfide, or with respect to carbon dioxide and carbon monoxide, all these statements are the most important statements that is required for your examination. So please remember all these statements very well, especially from the point of view of prelims examination, because in prelims we often see that they'll give you 3 or 4 sentences about each one of these pollutant or one of these pollutants, and they would ask you a question on that. So please do not overlook all these facts that we are discussing here. All these facts can become very important for the prelims examination. So let's move on to the next pollutant that we have, and these are particulates. So particulates, either it is called as particulate matter or PM, or sometimes it is called as SPM or suspended particulate matter. So it consists of a variety of solid particles and liquid droplets, small and light enough to remain suspended in the atmosphere for long periods. So this is the important factor. And as far as the Environment Protection Agency is concerned, it has classified the particles as PM 2.5 and PM 10. Why PM 2.5 and PM 10? PM 10 with diameters less than 10 micrometers and PM 2.5 with diameter which is less than 2.5 micrometers. So if you look at this line, approximately 62% of the suspended particulate matter in outdoor air comes from natural sources such as dust, wildfires and sea salt. Remaining 38% comes from human sources such as coal burning, power and industrial plants, motor vehicles, road construction and tobacco smoke. So this is the part that we are concerned about, 38%, because rest is something that can be naturally cycled in the atmosphere. Apart from that, particulate particles can irritate the nose and throat, damage the lung, aggravate asthma and bronchitis, and obviously shorten life. Toxic pollutants of chemicals such as lead, cadmium and PCBs can cause mutations, reproductive problems and cancer. Particulates also reduce visibility, corrode the metals and discolor clothes and paints. So please remember all these facts about particulates. Then the next one that we have is ozone, and this we will discuss in great detail when we come to ozone layer depletion. But for now, please remember these facts. First of all, this is also a colorless and highly reactive gas, and it is one of the major ingredient of photochemical smog. Then it can cause coughing and breathing problems. It can aggravate lung and heart diseases. It can reduce the resistance to cold and pneumonia, irritation of eyes, irritation of nose, irritation of throat. All these can happen. And finally, it also damages plants, rubber in tires, fabrics and paints. Now there are two kinds of ozone that we generally discuss. One is called as bad ozone and one is called as good ozone. So bad ozone and good ozone. So what is bad ozone and what is good ozone? So first of all, the ozone that we have on the surface, or you can say which is in the troposphere, this is called as bad ozone, and the good ozone is the one which is in the stratosphere. And why good ozone? Because it protects you from the harmful UV radiations of the sun. So now chemically both are same, both are ozone, O3, but one which is in the troposphere, which is in the lower part of the atmosphere, that has started to cause problems. All these difficulties that we are discussing happens because of this particular ozone. Now there are evidences that have suggested to us that there is a decreasing amount of beneficial or the good ozone in the stratosphere and an increasing amount of harmful ozone in the troposphere near the ground level, and especially this is there in the urban areas of the world. Next we have volatile organic compounds or VOCs. So organic compounds that exist as gases in the atmosphere or that evaporate into the atmosphere are called as volatile organic compounds. So why organic? What is the meaning of organic? Anything that contains carbon. Anything that contains carbon. So it can be an alkane, like you have methane. Right? It can be an aldehyde. It can be a ketone. So we are very much aware that this methane comes from the fossil fuels and is a major source of pollution. Then aldehydes and ketones are actually part of the smog problem. So all these are volatile organic compounds. So the examples of volatile organic compounds are hydrocarbons that are emitted by leaves of many plants, and methane, which is a greenhouse gas 20 times more effective per molecule than carbon dioxide, is at warming the atmosphere through the greenhouse effect. So as a greenhouse gas, methane is much more dangerous than carbon dioxide, although most of the discussions that we do is always around carbon dioxide. There is a reason for that, and that is that the amount of carbon dioxide that is being emitted all throughout the world is the highest as compared to all the other greenhouse gases. So that's why most of the times the discussion is always in and around carbon dioxide. But as a greenhouse gas, methane is much more dangerous than carbon dioxide. Now let's look at the sources of methane. So 1/3 of global methane is coming mainly from natural sources like plants, wetlands, termites. The rest 2/3 is coming from human sources. These are rice paddies, landfills, oil and natural gas wells. All these are the sources. Then apart from that, there are volatile organic compounds which are liquids and that can evaporate into the atmosphere. For example, you have benzene and some other liquids which are used as industrial solvents, right? Then apart from that, dry cleaning fluids, components of gasoline, plastics and other products.